Hello everyone. This is Dilleswara Rao from Aeronautical department. So I've been discussing on automatic control of aircraft sessions from last 3-4 classes. So we are continue with our last session. So in the last class we've discussed on self-contained guidance system and self-contained guide path system also we have discussed on. So self-contained and guide path systems are just we discussed on what is the types of self-contained systems are there in missile guidance. So in missile guidance only how that self-contained systems have been installed in missile path and how that systems will be completely calibrated with outside atmospheric things, and whenever the types of systems and types of tracking and what are the measures we need to take for make it in clear, and how that types the glide path when we are giving that glide path to that and tracking system for a missile if you are making it, then how it will be perfectly match with like whenever we are setting a target, how it will be setting that target achieve the target easily, and how it clear the target and what are the glide path variations, and what is the measures we need to take for making that in precise way, and what are the things we need to taken care for the glide path variation also we have discussed on last class. So now we will go into the session with automatic tracking system. So automatic tracking system of missile also is one of the major control system and control system need for a missile missile guidance. So like automatic tracking is for whenever we are launching a missile from one a launcher, that should be in such a way that it should clear the things. It should automatically it should track by the remote location, or self-sustained system in inbuilt in missile should track the outer atmospheric things, and it should track the targets whatever we have set for that missile also it need to taken care. So let's go into the topic. So let's see some introduction about the topic. So in any fire control system, target tracking is the means by which the target parameters are measured with respect to the tracking station. So the parameters here we are considering are azimuth, elevation, range, and relative target velocity are ultimately the predict the collision point between the target and whatever the weapon is launched against that one. So like azimuth and elevation will be like when we are planning a missile launch. So the missile should have a azimuth azimuth elevation. Like azimuth means what? Whenever the surface is there and one virtual surface is placed over the earth, then this surface will be like a virtual plane that has been created above the surface, and that should give one like a target area. I mean, in this area it should be focus on doing cruising level, and the elevation and range also. The elevation means like whenever the launcher is placed, that launcher should be elevated to that point in such a way that it should make that the elevator should make the elevation angle should be in such a way that it should match that azimuth angle also. Like azimuth angle will be like when you draw an angle with surface, when you draw you angle with surface, then this azimuth angle and elevation angle will be perfectly matched with the launching pad direction also. So before any computation or launching can be accomplished. However, the critical targets parameters must be continuously and accurately should be measured. So this process measurement is not exactly it not exactly do with same thing, where there will be some errors also will be present on this one. So the line of sight, like whenever we are setting a target to that missile, the line of sight area also between the sensor and target, along with the radiant energy from target, should be received by sensor is used to track the target. So if the tracking element were at all times directly along with the line of sight, then tracking would be perfectly and no error would exist. Like when we are setting a target for a missile and which is in within the range of line of sight, then it should uh, I mean it should perfectly reach the target and without any errors in between the flight. So it should be achieve the target in a better way. So the combined effect of weapon platform role, like the movements we are giving for that missile will be like a roll movement or pitch movement or yaw movement, will produce a disturbance to the tracking system, because whenever we are tracking that missile, and that missile is having in between motions also, like in between movement, like pitching movement or yawing movement is there in between, then it will be a big problem for tracking that missile. So that type of things should be, it should be designed in such a way that, the small disturbances also it should carry out. So the rotational motion not only affect the tracking element ability, but hold the target, but also generate the erroneous output data. Like that rotational movement, like whenever it is rotating, like a missile is going like this, and if it is getting rotated with like a rolling movement is there, because it is need to avoid the wave in way which way it is going on. So if it need to change its paths, so that rotation motion will also will like that rotation motion also will be in a way that it should track by the system. So since the basis of relative target velocity, the computation is an accurate measurement for a target position over time, so that uncompensated rotational motion of a weapon platform would result in erroneous target velocities being generated. Because when we are giving when we set the target for the missile, and in between it is having unusual rotational moment, so that will be like we need to track that movement also, so that it will be another output data, and that output data need to analyze analyzed by the system, and that will be another burden for the thing. So the tracking radars required separate components for range and angle tracking of a specific target. Like whenever the target is moving on the surface, like we are aiming from surface to the air, and this object is moving anonymously, then we should track that target in precise way, so that the missile will exactly hit the target, and it won't be miss that thing. Like whenever if it is having a movement of rapid movement also, it will track that movement, so that it will automatically attain the target. So these functions were performed nearly by the radars, and the watching the target video, then positioning the hand wheels to maintain the markers over the designed target blip and its scope. So the hand wheels positioned hand wheels positioned in such a way that the potentiometers, which was adjusted voltage analogous to target azimuth, elevation, range, and that will be supplied to fire control computers and lead computing gun sites. Like while we are achieving the target in like while we are achieving the target, and the tracking of enormous movement of the target tracking also we are doing. So then what will happen? So that missile should track that rapid movement also, and for that missile itself won't be track that one. So the radar should do the additional components like single wave system may not be tracked in such a accurate way. So some components of our radar system also should be included with it, so that it will track that radars accurately, track that target accurately. So usually the tracking lines lags in line of sight by some small amount. So due to that, the general mechanical tracking system anticipate target movement, because whenever we are tracking, like the missile launcher is like that, and it will have a handle maybe like this. Though, so that the handle should be, if it is a surface to air module, the air target, then it should be by mechanical means, maybe with hands or maybe with the automatical motors. It needs to track. Maybe like this one, like a gimbal system. It will be tracked. It will aim at the target, and by moving like this, so that movement will be by means of mechanical movement only. But in terms of that mechanical movement, may the error will come, so that it may miss the tracking of that target. So this problem can be minimized, minimizing the error. The errors define the central problem at any tracking system. So how we can how we can overcome that line of sight error and the tracking line to reduce the acceptable minimum average value. So this problem can be minimized by making the line of sight and the tracking line is further completed by fact that weapon platforms are not generally stable. Like, because when we are moving the target like here to here, or maybe we are tracking the target by moving that launcher from here to here. So the line of sight may having some errors with the tracking system. So to avoid that one, the additional components only we need. So how it will be avoided? So that will be like the error defines the central problem at 80 tracking. How it will be defined with them? So that generally we need to avoid that one. So we will have different types of components need to be uh, adjust with that one. So on that way, different types of components are like one of the thing is like angle tracking servo system. So angle tracking servo system means what? So here, while we said no, by mechanical means we are setting the angle and azimuth elevation of this missile. So if that missile is we hold like this, or maybe with a mechanical means, or maybe with a motor, we hold that tracker, and the tracker will be aimed like this. If we aim that one, so if we aim that one, so by aiming, we may miss that thing, while movement only, due to the rapid movement, it may miss that target track. So to avoid that one, how much angle it is moving, and that angle compensation also we need to include. So how we can compensate that angle errors? So for that, one system we are giving here is angle tracking servo system. So this is like, once a target position error signal has been extracted from the returning energy, so it forces input to that azimuth and elevation drive servo system. While it is targeting like this, so once that error has been come, if it is not tracked, so between the target and its elevation, there will be a slight error. This signal will be in this way, suppose like this, and this signal will be this way, but here the target will be in this way. So that means there will be some gap between that one. So to avoid the because it is moving like this, so due to that angle adjustment, it is missing that target track. So to avoid that one, first the positioning error, it will detect that positioning error. In this position, if we place that one, it will miss the target. So the positioning error will be given a feedback to that system, then that will activate the servo system. So these systems, like so the system keep the antenna pointing at the target. That is they serve to minimize the error between the LO's line of sight and the tracking line. So the tracking servo system function conceptually in same manner is like aiming that thing, like a gun we have followed, and if we are seeing with a telescopic view. So on the telescopic view, if you miss the target, then again we will see and we will aim to that one. So like that, here the automatic servo system will aim that one. So the aim will be in a line of sight only, because the video system, video input is given to that one. So that video will show you if it is in that line of sight or not. So if it is in that line of sight, then it will automatically lock the target. So for that, what are the means it need to have? That is like the functions. I mean, the things it can do is like they sense the position at magnitude and direction. They provide position feedback, and the data smoothing and stabilization also it can do, and velocity feedback to aid in achieving the smooth track, and power driving device also it will have. So these are the functions the system can have. Like it will have a positioning error detection. Like if it is error is being positioned, then it will detect that error. Then that error feedback it will gives to the system. Then the stabilization of that error, like the error data analyzation, it will do now. Like this much of variation is there with line of sight and that target. So that error should be minimized, and according to that, it will set its line of sight. Then provide velocity feedback, and like whenever it has to launch or it need to move rapidly, so that feedback adjustment feedback also it will do. And power driving device, like if additional power is required for tracking that movement tracking, or maybe with that launch movement also, that also it will serve. So this function performed by radar itself, it is like a radar itself in conjunction with continuous circuitry that has been designed specially for this type of angle tracking radar. So especially one radar is designed for this angle tracking thing only. So from the study of sensor subsystem, generally the output of a sensor is target position data, and that this data available only when sensor is pointed at the target. So the target position should be available for weapon control system, and also some means of detecting the target motion is required to sensor this sense to follow the target. And the target information enters into the sensor from beam energy. So the energy concentrated along the axis of beam, like when the beam energy only, the sensor is being track that system kind of perfectly, so that this radar can detect that the target easily. Like you see, the sensor also is there. That sensor will create the information, so that it will get the information, so that it will set the line of sight, and that elevation angle also it will be setting automatically. So the block diagram of angle tracking servo system is like this. So see here, one separate block will be there, like angle tracker, angular detection, and primarily one transmitter, and the receiver is there for getting the signal. And this is the radar dedicated for this tracking system. So the duplexer is like a it is giving the signals like a double signals, like double signals it will generate. And the range and the Doppler gating, time frequency things also it will have, like these are all electronic systems only. So when its main function is like, if it is transmitting the signal, and first it will track the target. Like if it is a target is like that, and you see if it is having a range of like this, and here the target is there. So the target will be first, the radar will get the target, then it will receive the signals from that, because whenever it is transmitting the thing, so that some energy will come from there also. Due to that energy, it will receive that thing. Then it will the positioning thing and the angle error calculation will have, like here to here, if any angle error is there, that error detection also it will do, and that will gives the feedback to the servo control. That servo control will give the input to that radar. Then accordingly, that radar movement also will change. So that it may be like this, or then after detecting the signal, it will be the signal range will be like this. So that it is in the range of this radar. So once that it is there in the range of that radar, then if it is if this movement is rapid also, according to the movement, according to that target movement only, that radar also will move. For that moving system also, there will be some mechanical means and automatic means also will be there inside. Okay. Next, sequential lobbying. So lobing means here we are creating one big type of signals we are producing. That signals will be creating the range of that target. Like if it is lobes, maybe like this. So these are the lobes created by the radar. Within that only, that means it will sense if it is here, this direction or this direction, so that it will sense the signal. I mean, send the signals within this range, that target is there or not. So these are the lobing of signals. So this is the system, like what it means. Like it's a tracking method developed by lobe switching or sequential lobing, which is still in use today by many countries. And angular error and the orthogonal coordinate is designed with simultaneously. The beam could be stepped in a minimum of three. Usually, like a three position lobe beam should be there. So for the signal comparison, the process is called sequential lobing. Like I said, no, minimum three position lobing should be there. Maybe in, like that, three directional lobing. So this in this three direction, it will send that signal, so that within the signal, that means it is covering all entire the area. So it is sending the signal, so that automatically it will receive the things from. I mean, automatically it will detect the target. So the stepping process is limited by PRF of the radio frequency of system, and the beam position must be stepped along with at least one transmission, and one transmission and the receiver should be there, and echo, and probably more prior to switching the next position. So four separate antennas or separate feed horns will be required for this system. So the complex waveguide plumbing and switching techniques also required for operating this system. Like four antennas should be there, so that that antennas will be in such a direction, like the lobes will be sending. I mean, lobes will be created in all the direction. If it is a four lobe is there, then it is having wider range of directional thing. So that means if it is in this way and this way and this way and this way, four direction, it is sending that like maybe in that top you can see, like it is creating here and here and here. That means all over the all over like a flower only, all over direction it is sending the signal, so that if within the signal, if it is getting tracking, it is getting the track or not. So that means it will do. So you see here the sequential lobing positioning, how it will be. Like a position is like that, and if four axis position is there, and how that amplitude and the positioning is given here. So see, the lobes have been created like that, If it is creating the signals in this type of thing, so automatically it will get the signal. Get the target if it is in the range. Even out of range also, it will detect like in which way the target is moving. So the target movement also it will be it will create. Target moving also it will do. Then conical scanning. So conical scanning, this is also one type of thing. Like conical scanning means we are creating the lobe within the short range only. But even with the, if the range is up to here, but outside this lobe, it may lose the information. So to cover that outside surface also, that conical type of scanning, like a conical surface, if you follow that surface scanning also it will do. So in this way, how it will work, like it's a natural extension of the beam stepping process. So four position is to rotate the beam continuously and circular fashion. So the error between the tracking axis and line of sight can be sensed with magnitude and direction by causing the radar beam to be rotated rapidly, and the axis of antenna will be axis of antenna will also be set in that position, so that will produce a narrow cone of energy in space. Like it is it is creating the space so that the axis and line of sight errors will be minimized. So the general accomplished, and generally it will be accomplished like mechanically by notating the feed point, like rotating the feed horn, and the small circle around the focal point of focal point is a fixed paraboloid, and the antenna beam with will be along the axis of reflector only, like antenna beam also, like you see in a in a picture. If you see like this, so here the radar is there, and here the paraboloid axis point and focal point is near the focal point the beam is being generated, so that it is creating the beam but in a conical position, like a conical position. It is creating the signal of beam. See here. So if it is a radar like that, and the antenna beam is like that, the beam axis will be in this way, and squint angle and rotational angle. That's this conical thing will be rotate like this. That means all over the area it is been covering, like one big circular thing will be rotating, like waves only will rotate like that. So that what will happen? This will entire. If the target is like that, that will be entirely covered with with this signal, and that line of sight also will be arranged. Uh, like you see, in actually the pulse radar is employed with PRT less than that nutation period. So that nutation means rotation of that axis, and the rate of beam rotation must be such that several pulses also radiated. Several pulses radiated energy will be exchanged with the target during the period of beam motion. So in actual practice, the radio frequencies is approximately from 40 to 1, where it is where the frequencies is scan frequency, and PRF is the pulse reception frequency of the radar. Then the line of sight and the tracking line are coincident. Then target is exactly on the target line successive line, so that the thing will be easily. Whenever that line of sight and tracking line angle are match, so that it lock the target. Lock means it has tracked the target perfectly. So if it is moving also according to that movement only, that conical shape also will move. That means within this range only the target is moving, so that the missile will aim to that target easily. So the conical system is the block diagram of a conical system is like that. like same in radar system only. The transmitter, duplexer, and will be there, and receiver also will be there, and the sensor detector, like second detector will be like if it is when one angle is, in one angle it is showing that line of sight, and another angle it will it will see that whether other positions are covered or not. Then the elevation servo amplifier and elevation angle detector and azimuth servo amplifier and azimuth angle error detector, these will be serving that things like see here the rotation of motor, like this is for azimuth motor and this is for elevation motor. That means automatically if radar is like that, and that scan radar you see here the rotational rotary point of antenna, like antenna is like that, it is rotating rotating by means. So if it is rotating by means with these motors, then if it is rotating with these motors, then that while rotation only it will aim that levels like azimuth azimuth angle, and the elevation also it will be automatically set with this servo motors. So that motors will detect the error by sending the signals to the target, so that due to according to that signal and the error detection, it will rotate that one, like maybe like if it is this one, and it will rotate like that, and automatically it will the angle and the elevation also will be set like that. So that means angle is will be like this or like this, and azimuth angle also will be maybe like this or like this, it will rotate. Then that that radar also will be rotate in front. So however, the target is not exactly in the antenna's axis, but error exists between the line of sight and the tracking line. So this error will be immediately detectable, and the beam rotates, and the return pulse or amplitude are modulated due to the varying proximity of the target and the beam center. So the frequency of modulation is the scan frequency of the system, and the concept of amplitude modulation is the sensor input signal, and it's not limited application to active radar system, like it not be limited to some things only. It will be out of if it is out of range also, it will be making that perfectly. Then corso. So COSRO. So COSRO means conical, scan, and received only. Like conical, scan, and received means once it is while we are making that while we are scanning, like scanning means what, we are targeting the angle. If it is targeting also, and it will receive that signal from there. So automatically it will track and receive the signals from the target. So this is like it's achieving a degree of immunity and deception in from inverse conical scanning. That inverse that is ECM, a system known as COSRO was developed. Like the immune whenever we are whenever the detection errors have been detected, so that to compensate that errors, this COSRO system was developed. So this means we said, so this is like a new scanning it employs a non-scanning transmit beam and a rotary scanner in the wave guidance between duplexer and the receiver to exact the elevation and azimuth angle error. Like when it is having a non-scanning transmit beam, that beam will be that beam will be track the errors between that azimuth angle and elevation angle errors, so that it will exactly give the positioning to that radar system, so that it will automatically adjust the things. So a receiver in a target being tracked by Corso radar, that will be detect it's a steady non-scanning pulse radar beam, and it will provide information that will be assist in determining the deception technique beyond the radar performance parameters. So this is like that. Like antenna is like this, no? See here, antenna is like that, and the lobes are been given like this. So the transmit pulses axis of the antenna is like this, and the measured strength of return round axis of the antenna also been given like this. So the positioning of the antenna based on the written deception only. So like a non-scanning pulse radar. Non-scanning pulse radar means yeah, it is scanning that target, even though if that target is out of the range, also that error detection, I mean error between the elevation and the azimuth things will be detected automatically. So due to that, it will I mean it will track the target easily. So this scanner is a effective shifting of the axis of greatest sensitivity. So echo reception similar to that slight change in the detection and a detection in the transmission of beam transmission. Like beam transmission means that signal beam created. No, that signal beam transmission of conical scan radar caused by that mutation of feed horn. So I mean, we can imagine like the receiver beam is similar in shape with the transmitted beam. Then it being mutated about the radar bore sight axis. Like radar bore sight axis means if radar axis is in one way, and that receiver beam and transmitter beam also in same direction, so that it will adjust that beam position. And this scanner determines the distribution of a signal strength and received by the energy, and RF signal detector rotated by the motor tachometer. Like if RF signal rotate, like it has to rotate around that axis, no? So that rotation things also it will be detected, so that rotational moment also it will be adjusted in such a way that it will give the it will achieve the target easily. So the location of greatest amount of returned energy is there determined. The signals are sent to that elevation and azimuth power drives. The drives to reposition the antenna and the center of the target. So when the target is centered, like when the target is in a center, the Khosrow scanner will sense the equal signal strength throughout the rotation of RF signal detector. So this concept can be employed with sequential lobing radars to produce a lobe or a receiver only. That is called LoRo radar. Like that means what? In the lobe radar, we are creating a lobe over that thing, and the lobe and the receiver lobe also. The receiver lobe also in a perfect sequence, so that it is having the tracking of the tracking system and receiver system, and the feedback system also it will give to that radar data easily. I mean radar data perfectly. Then the monopulse system. So the conical scan the sequential lobing radars require a minimum number of pulses in order to in order to detect the angle errors. So in the time interval being during which the measurement made with earlier sequential lobing, the conical scan and the train of echo pulses must be contain no complete amplitude modulation components other than the modulation produced by the scanning. So if that echo pulse train did contain additional modulation components. So for example, the fluctuating target also in a cross section, and the tracking accuracy might be degraded. So especially if the frequency components of fluctuations were not near the conical frequency or sequential lobing rate. So pulse to pulse amplitude fluctuations of echo signal have no effect on it won't be have a separate effect on tracking accuracy. So there are several methods of angular error detection systems are there. So more than that, addition to this antenna beam, simultaneously there will be some methods that will focus on conical scanning and lobe switching tracker, which will use this that antenna beam and time shared basis, that conical scanning and that lobe switching, like a lobe will be like this one, and after that it will be maybe like this or maybe like this or like this. So when the lobe is switching from a position to one position to another position, so this will be in such a way that it will track that system. It will be adjust its angle error with rapid movement only. So the angle of arrival of echo signal may be determined with single pulse system, and the simultaneous lobing and monopulse will be used to describe the tracking techniques, which will be angle error information. So the widely used monopulse techniques are like amplitude comparison monopulse and phase comparison monopulse. So amplitude comparison, phase comparison means whenever we are creating that lobe thing, so that lobe amplitude and lobe phases also will compare. If it is in the same amplitude, so the range is up to there only. If the amplitudes are different, then it will be having a like if it is a amplitude or like maybe like this, so that the sequential lobings also will be created around this one, so that sequential lobings will be tracking. The sequential lobings will be designed in such a way that it will track that system arrow above the surface easily. So amplitude comparison monopoles will the two overlapping antenna beams by generating a single reflector with a lens antenna illuminated with two adjustment feeds, and some patterns used in transmitter while in same matter, or maybe the different patterns also will be used. And the different pattern provides a magnitude of angle error, magnitude for the angle error, and the sum of signal provides by range of measurement also used for reference to exact detection of error signal. So this is the amplitude comparison monopulse block diagram. You see here, if there will be the conical scan modulation or error detection system is here. So it will have inputs from the IF amplifier and second detector and video amplifier and a range gate and boxcar system, and one DC amplifier and AGC filter also. This filter system is for producing the signal and producing the signal clearly, and make that amplitude changes to that signal provided by this IF amplifiers. So amplifier means what? It is modulating, or it is improving the signal strength. So maybe the frequency or maybe the amplitude, so that things will be improved by using that amplifier. And this video amplifier is like when a line of sight is being line of sight means the camera is visualizing the things around that radar, and that video things also will be giving through the signal, so that will be in such a way that it will have a good signal. Then only the clear vision will be there for that radar. And monopulse comparison method, it's like another tracking method. So in this when echo signals will be received from two or more antenna position. So sequential lobing conical scan techniques are used in single or time shared antenna beam, while the monopulse usually will be two or more simultaneous beam. Single beam or the conical scan will be depending on single beam rotation only. Maybe with the single beam axis only it may depend, but this monopulse will be depend on at a time two beams. At a time two beams will be created based on that signal range only. It will detect. So the difference between this amplitude in several antenna positions was uh, was be proportional to the angle error. The angle of arrival may also be determined by comparing the phase difference between the signals from two separate antennas. Like the angles are maybe different, then the difference between the angles also will be compared with the phase difference between antennas. Like one antenna is creating this much signal and another antenna is creating maybe this much signal. So between the phase difference also it will compare, it will analyze the data. Accordingly that it will do the modification. So this is the monopulse comparison. Like see here, one angle lobe things are maybe like this, or maybe that pattern signals maybe like this type, or maybe some separate lobe things also will be like that, and a single beam or single elevation type angles also will be created, so that this type of different patterns will help, like it will gives you the more comparison with more detection range for the antenna, so that it will at a time it will detect the signal. At a time it will detect the target easily. Like these are all for tracking of missile only. Like missile is going on cruise condition. So, or maybe the target is coming to our state, like enemy missiles are coming to that, so that we need to see whenever that enemy missile enemy country is launched a missile, that missile is coming to us, if it is in that line of sight, or if it is not in that our line of sight, how to make that visible in our line of sight, and accordingly that how this launcher will be positioned, and this elevation and range of that missile also how it will be designed, and the radar also while tracking for enemy's target, how this radar will be designed for tracking that outside atmospheric things, and outside enemy targets also how it need to achieve. So that things will be taken care by using this monopulse and amplitude comparison, or with conical scan coarse rope, or LoRa type radars, or monopulse radars. So these are all radar systems for only for just making that clear vision for the launcher. So these are the references we have taken for getting the information. So in this session, we have covered the topics related to the radar tracking system. So in the radar tracking system, how many radars are there, how many types of radars are there, and what are the methods involved in that radar tracking, and how that radar signals will be improved, and what are the means for making that radar should be position the target easily. So those topics we have discussed on this. So in the coming section, we will see that stability type aircraft stability related topics. We will see it on coming classes. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.